And welcome to another edition of AppSec Decoded. I'm Taylor Armerding, security advocate for the Synopsys Software Integrity Group. And once again, as you can tell, we are amid the exuberant chaos of the exhibit hall at RSA 2022. But we're here to talk about decoding AppSec. What else? And today, our focus is on an element of President Biden's executive order on cybersecurity, which is securing the software supply chain, which is and can be a somewhat complicated effort.
That's an understatement, it really is.
It really is, all right. Evidenced by the guidance issued last month by the National Institute of Standards and Technology, better known as NIST. That document is 326 pages long. It contains an array of security practices for any vendor that wants to sell software products to the federal government. So with me today is Tim Mackey, security strategist with the Synopsys Cybersecurity Research Center, better known as CERC. He is our go-to guru on the topic. He read the whole thing. Not only that, he annotated the whole thing. So Tim, thank you very much for being here. And it seems to me, looking at your annotations, which were very helpful, really, looking at those annotations, that a number of the recommendations, guidance, practices, whatever you want to call them, are things that the security community has actually been preaching for a while. So I'm just wondering how much that message is getting through. Do you think a critical mass or even a significant percentage of organizations are already kind of moving in the direction of or there with the guidance? Or are they close enough that just a few tweaks might do it or not?
So the fundamental challenge is, again, 161 is all about risk and risk-based processes. If I go and talk in terms of CVEs, well, there's this thing called the CVSS score that comes along for the ride, and it starts to express how critical this is. That's the criticality in isolation. The NBD and the folks that go and manage the data going into it, they know nothing about how you've actually deployed this application. They just know that this is really bad. I'm going to give it a CVS score of, say, 9.6. And this isn't so bad. I'm going to give it, say, a 4.2. And we actually see those scores move around. And for practical purposes, that's almost the generic version of the risk language that we've got. But like I said, it doesn't take into account the fact that you might have firewalls there, that you might have other mitigation and controls in place, that this thing isn't actually exploitable in a specific path. That's part of what 161 is talking about. It's like, how do I express risk? And how do I actually go and prioritize what I should be looking at first? So if we move to something that everyone's been working on since December, well, log4shell, log4j, really bad thing, high CVSS score, everybody needs to fix it. But is a fix a patch? Is a fix a mitigation? Is a fix a set of mitigations? Does a fix include monitoring? Now we're starting to talk in risk-based terms. And that's actually one of the bigger challenges, is just getting into that risk-based language and workflow. And to a large extent, that's going to help people figure out where to start. Because when you throw 100 findings at them, they can more or less figure out how to start. You throw 1,000 findings at them, it's like finger in the air.
It just turns into noise.
It turns into noise, and inevitably someone goes and throws their hands in the air and says, gee whiz, but this is hard and I don't know how to manage this, and gets grumpy, and then worst case turns the tool off because it's not doing what they hoped for, or it's creating more work.
Several things from the list that you provided. You provided a list of what were kind of like the, let's say, the major points. One of them is ongoing risk-based assessments of software supply chains should be done. In particular, whenever new code is created, or delivered, which I suspect happens a lot and could take time and money.
Just think of a DevOps pipeline. This is happening on an almost daily, multiple times a day basis. Yeah. So, sorry.
Okay. All right, no, that's okay, but I mean, it happens a lot. Supply chain risk requires direct management and should not be a secondary function of another team. All software must have an associated software bill of materials, or as we know it, SBOM, and cyber supply chain risk management starts with an inventory of all suppliers and their associated contracts, and those contracts should include provisions for termination in the event of a poorly addressed cyber event. So, will doing all these things and more significantly raise the price of software products?
one of the important things to recognize is that when you're dealing with risk-based scenarios, there's going to be incremental risk, and there's going to be almost step function risk. Log4Shell, perfect example of step function. Evolutionary code, that's a different type of risk. So there's going to be all of these various categories of risk where there's deviation from original intent. One of the best examples that I can give is the concept of a foundational component that is created for some internal use. So it's not a supply chain in the traditional sense, it's actually looking at things in terms of being able to have an internal supplier. They go and they create this tool, this library, this whatever. It's meeting its requirements, it goes and gets used in something else.
Yes.
That something else maybe has a regulatory requirement. Let's say it's in a healthcare app. Let's say it's financial services. If the original team didn't know that that was the end result, they probably didn't test it to be compliant with PCI or HIPAA or whatnot. And there might be issues like how logging happens that would make it non-compliant. So that's an example of how the communication between suppliers really needs to happen, because the expectations of the team creating something may not necessarily align with how the something is actually going to get used in real life.
Okay.
Now, in terms of cost, there can be cost associated with this, but it doesn't need to be extreme.
Okay.
So there are ways of solving SBOMs using existing tooling.
Yes.
Black Duck is a perfect example of that. Remove the S out of SBOM and you end up with a bill of materials. It's what Black Duck has produced for years. One of the objectives of an SBOM when you get into an operational state is to be able to identify where vulnerable components are. Well, Black Duck has done that for years. You can put policy around things like, I don't like a CWE of something. I don't want to have code that's so old. Black Duck has done that for years. So for practical purposes, if you end up in a situation where you're like, well, I need to do something with this SBOM deal, maybe all you really need is an existing SCA solution that goes and does these things as the first step.
Okay.
So looking at things through a cost lens is also looking at things through the risk lens and trying to figure out, well, where do I start? I don't necessarily need to reinvent everything, but I do need to move myself towards continuous improvement.
Well, we really talked about a bit about SBOMs, but obviously if you need an SBOM for every single software product you have, isn't that thousands upon thousands?
Potentially.
Yeah, okay.
Potentially.
But if you have a
hundreds.
system or an automated system in place where you can do that,
like a Black Duck that can go generate these things, exactly. But here's the real kicker. So when it comes to something like an SBOM, simply having the physical document, well, without the process and the workflow, what are you going to do with it? Stick it in a file cabinet someplace where it's going to collect dust? Or the moral equivalent of back it up onto a thumb drive that's in somebody's desk someplace? It's absent the process, there's no point in asking for the SBOM. So when the time comes that you're required to go and create SBOMs, one question to ask whoever's requiring you to deliver it, so what are your expectations for the use of this SBOM? What do I need to do in addition to just giving you this file?
Thanks very much, Tim. We're going to leave it there. We've been talking about building trust into your software supply chain. I'm Taylor Armerding. We're here at the RSA 2022 conference. I'm with the Synopsys Software Integrity Group, where we help organizations build trust into their software.